Hello students. In this video I will discuss a problem based on numerical aperture. So let's start this video. So I have written a numerical which was asked in GATE 2010. The question is, light coming out of an optical fiber is incident on a plane perpendicular to fiber axis. Means if optical fiber is placed like this, there is a surface perpendicular to the optical fiber. Light coming out of optical fiber falls on that perpendicular surface and which is 50 mm away from the end of fiber. Suppose this is the optical fiber, light coming out of this falls on a perpendicular surface. This is the which is placed at 50 mm away from the fiber. This is optical fiber. This is our optical fiber. Light coming out of optical fibers falls on a surface which is placed perpendicular and how much distance is given? 50 mm away. So distance between optical fiber and that perpendicular surface is 50 mm. Now read, the light coming out of optical fiber creates a circular support. So the surface is circular, which is creating a support, circular support that can be at most be 20 mm diameter. So diameter of this support, so this is the support which is created on the surface. Diameter of this support is 20 mm. So this distance is 20 mm diameter of this circular support. Now neglecting the diameter of fiber, the numerical aperture of fiber is, so question is asked numerical aperture of this optical fiber. We are given this information. See, from this information we can calculate this angle. What is this angle called? Acceptance angle, right? So from, if we calculate this angle, this is acceptance angle, and we know the from acceptance angle we can calculate the numerical aperture. So if total diameter is 20 mm, so half is the radius. So this distance will be 10 mm. Now looking into this triangle, this distance is 10 mm, this 50 mm, and theta is, that is acceptance angle. So from this triangle we can calculate the acceptance angle. This theta is, if we solve, tan theta is equal to, that is equal to a perpendicular upon base. So 10 divided by 50. So theta is equal to tan inverse 1 by 5. So that will come out to be 11.3. Now we have to calculate the numerical aperture. So this medium is air. So numerical aperture, that is equal to sine of acceptance angle. So this is the relation between numerical aperture and acceptance angle. So acceptance angle is 11.3. So sine of 11.3, that comes out to be 0.19. So numerical aperture of this optical fiber is 0.19. Thank you.